Hey y'all, in this video we're going to talk about kites and derive some of the special properties that this figure has. So let's start off by refreshing our memory on what a kite is. It is a quadrilateral that has two sets of congruent adjacent sides. And remember, adjacent means right next to each other. And in terms of polygons, that means they share a vertex as an endpoint. So EK and IK are adjacent sides and they are marked as congruent. ET and IT are adjacent sides and also marked as congruent to one another. Therefore, this quadrilateral by definition is a kite. Now, when we worked with kites, you might have suspected that there are some congruencies going on here other than these two sets of sides, and there might be something special going on with the diagonals, and we are finally at a point where we can actually prove those things. Now, in order to do that, I basically have to turn this kite into triangles. And I don't have enough line segments to do that, so I have to add them in. And whenever you're trying to prove something and you have to add in a line segment like a diagonal, you are going to be able to do that because of this property called the line postulate. And it states that there is exactly one line connecting any two given points. Now, a postulate is a different word. We're used to having like conjecture, but postulate is something different. It is a property, but it's a special kind of property. It is a property that we accept as true without proof. They are the fundamental properties that make geometry work. And in Algebra 1, we called those fundamental properties axioms. Those were things that we accepted without proof. Like the commutative property of addition, right? We accepted that A plus B was the same as B plus A. And in this case, in geometry, we accept that if I have 2 points, there is only one line that goes through those 2 points. And this is what we need to use as reasoning when we have to add in line segments, like diagonals. So in these two drawings, I have drawn in the two diagonals separately because they each give me different things. So looking at this diagonal, you should immediately see what's going on with those two triangles. What type of triangles do I have? I have isosceles triangles, and I know a whole bunch about isosceles triangles, right? I know that this angle is congruent to that angle, and I know that that angle down there is congruent to that angle down there because I have isosceles triangles, right? And I also have special vocabulary. This K we called a vertex angle, right? Angle K is a vertex angle, and angle T is similarly a vertex angle. Now, they were vertex angles of the triangles, and that's actually what we call them for the kite too. Kites have vertex angles, and they are like the vertex angles of the isosceles triangles that the kite is really made up of. And you want there to be a special name for E and I, but there's not. They're just non-vertex angles. Fancy, right? Non-vertex angle, right? So additional vocabulary, vertex angles, non-vertex angles. So going back to what that diagonal gives me. So that diagonal gives me the two isosceles triangles. Therefore, I know the base angles are congruent. And I also know something super special about isosceles triangles from our work with the points of concurrency, right? Those are the centroid, the orthocenter, right? Those points of concurrency. I know that, let's say I can construct the angle bisector for K, right? Those two angles are congruent, right? I know that the angle bisector of the vertex angle of an isosceles triangle is more than just the angle bisector. It is also the median, right? Cuts the base in half, and actually I have to put two more things there. And it's also the altitude, which means it's perpendicular, right? Now, this line, KT, happens to be the other diagonal, and it also is the angle bisector down here, right? So really this line is the Euler line for both of those two isosceles triangles, right? And it gives me a whole bunch of properties here about this kite. It tells me that the diagonals are perpendicular, right? So KT is perpendicular to EI. The two diagonals are perpendicular. And I also know that KT bisects EI. KT bisects EI, right? So I've got all of that. Perpendicular, bisecting, yay. So that's what this one little diagonal of the non-vertex angles gives me. So now let's look over here, and I look at this diagonal here that connects the two vertex angles. And immediately when you see this drawing, you should say, oh my gosh, I've got two congruent triangles here, right? Because the reflexive property allows me to say that KT is congruent to itself. So therefore I have two congruent triangles by side, 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 KIT, right? And KET are congruent. And if those two triangles are congruent, then I know that this angle here has to be congruent to that angle there, right? By CPCTC, or corresponding parts of congruent triangles are congruent, right? Has to be, right? Nothing else can be true. So now just being able to add those two diagonals in, I can prove so much. I have perpendicular diagonals. I have one diagonal bisecting the other. I have one diagonal bisecting two angles on the kite. And I have the non-vertex angles being congruent, all from just knowing a little bit about triangles. So if I want to break it down to the actual conjectures that I have four. C35 is called the kite's angles conjecture. It says the non-vertex angles of a kite are congruent. C36 is the kite's diagonal conjecture. It says the diagonals of a kite are perpendicular. C37 says kite diagonal bisector conjecture. The diagonals connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. And then finally, C38, the kite angle bisector conjecture. The vertex angles of a kite are bisected by the diagonal. Now, you may notice that I didn't actually write up a proof of anything. All I did was I drew in a diagonal and I saw what it gave me. Gave me isosceles triangles, gave me congruent triangles, and from all that, I have these four conjectures. So now here's what I need you to do, okay? Two extra things. I need you to go back into those conjectures and draw the pictures for them and mark them, okay? So that you have a visual of what those conjectures say, okay? Now, second thing is I need you to think about how you would write up a proof for each of those conjectures. What are the steps you need? What do you have to add in? What allows you to add it in? Because you may have to do that on your own or in your group in the near future.